Okay, what we're going to look at here is just how to find the plane director of a hyperbolic parabola. So here we can see our basic setup. Over here we have our coordinates. So again, it's in, up and down, coming from our datum point each time. And we can see we have AB, our skew line number 1, and CD, our skew line number 2. So the idea here is that we want to find the single plane that is able to contain the line CD, move along, and then contain the line AB. Part of our definition of our skew lines is that they can't be contained on one single plane at the same time, but they can be contained on a plane which will move into a new position and contain the second skew line. So starting in, we'll just go through the question. We'll set up our skew lines like so. So there's our skew lines A, B, C, D. The first thing we want to do here is find out the plane that can do what we're looking to do, so contain the two skew lines. Now, because it can't contain the two of them at the same time, what we need to do is pick one of our skew lines and let's make a copy of it so that it's connected with our second skew line. So if we call this skew line number 1 or our original, we're going to copy this skew line onto this skew line here, and we're going to make a little triangle out of it, or a little lamina or portion of a plane. So just connecting up for our hyperbolic parabola, we're going to take one of our points, and at this point it doesn't actually make any difference which point you take. So I'm just going to take this point here to start with, and I'm going to draw my skew line parallel. So this is my copy of my skew line. If it's a true copy, it must be parallel in both views, both elevation and in plan view, and once they're truly parallel, they'll be parallel in all views. So from my point here, I go parallel and I just draw a level line to make my little lamina. So this triangle here contains my original line here, so skew line number 2 we'll call it, and it contains a copy of skew line number 1. So when my plane moves into its new position, because it's contained the copy of it here, I know when it moves along it will be able to contain the original. So with my lamina here, and another little point is my line here is a level line, and just going to a little 3D view here. Here's our plane like so that we're trying to create. This is our little triangle or portion or lamina of our plane. We can see because this is a level line, it's going to be parallel with my horizontal trace. So that's really handy, because when I look from above into my plan view, that line, that level line in elevation, will be a true length line in plan view. And if we look along a true length line, we'll see it as a point view. So we can see, looking along it, there's the point view of it here, and we will see an edge view of the plane that it's contained on. So this entire plane that we're dealing with here will be seen as an edge view, and this is why all our generators are all parallel, because when it's in this position here, as it moves into our new position, you can see it hasn't changed angle, it hasn't changed slope, it's able to contain all my generators all at the one time. So that's our parallel line in elevation, our level line in elevation. Now we need to repeat the process in plan. So if we've come from this point in elevation, we're going to go parallel from it in plan view. So there's our parallel. So this is a true copy. It's parallel in elevation, it's parallel in plan, so it is a true copy of it. Where my level line meets my copied line, I can take that down and complete my lamina or my triangle in my plan view. So this is my true length line. So by looking along my true length line, I'm going to get my edge view of the plane, the point view of the true length line and the edge view of the plane. So draw my x1, y1 line perpendicular to it, project up my points for my two lamina, lamina 1 and lamina 2, and you can see the two are parallel, and this is the proof that we've found our plane director. Our plane director is seen as an edge view in this view, and we would expect to see our two lamina or two skew lines parallel. So this is proving that we found the plane director. So there's our true length line. There he is seen as a point view. And to find the traces of my plane now, where my plane director cuts the horizontal plane and the vertical plane, I take either of my lines. Usually in the question you'd be given a specific line or generator to take. So in this case we're just going to take the example of this skew line here, and I'm just going to draw in the edge view of my plane director. To find my traces, where my plane director cuts my x1, y1 line, that's my ground, I just project him back along, and there's my horizontal trace. So here we can see our horizontal trace and here we can see the point view of our horizontal trace. So we've worked backwards. We have the point view, and now we've found the trace. We can also see that our horizontal trace is parallel to our level line here. Both of them are contained in the same plane, and both of them are in contact with a horizontal plane. So both of them are going to be parallel. So there's our horizontal trace. To find my vertical trace, I can do one of two things. What I'm going to do here is I'm going to take my level line, which I know is on the plane. I'm going to continue him until he hits the XY line. That's my back wall, if you will, or my vertical plane. I'm going to bring him up, and then I'm going to continue him along here. So that's a point on my vertical trace. Remember, our vertical trace in plan view is along the XY line, my vertical plane in plan. So that means that this is going to be my point on my vertical plane in plan. Bring him up. When I know he's continuing this line in plan, so he'll be continuing this line in elevation, finding me the point. So that's my point there. That's my vertical trace. I could alternatively work with my auxiliary here, take a random point on my plane, take a point here, bring him back down until he hits the XY line. That will be my point on my vertical trace in plan view. I could bring him straight up, measuring my height from my auxiliary. I could mark off my height here, which will give me my point, my second point that I need. But either way is pretty good. The main points are, first of all, why we need to copy our skew line, setting the plane, what the lamina actually means, and how we get our edge view of our plane director here. So they're the key kind of learning principles. Hopefully that'll be some help to you.